Let's go with circles. Circles are probably the easiest of the conic sections because as we saw in our handout, if we've got x squared plus y squared equals some number over here, we're going to call it r squared in general. Because as we saw in the handout, we had x squared plus y squared was 25. Well, we had a circle centered at 0, 0, and the radius was 5. But notice there, 25 is 5 squared. And so if we have this set up on an equation, x squared plus y squared equals some number, and we'll call it r squared, yeah, that's going to give us a circle centered at 0, 0. We'll talk about shifting them next time, but this one's just centered up at 0, 0, and then the radius is whatever the square root of that is. Radius is r. Yeah, this is going to be r squared, so we square root it. And that's going to be the radius. Whatever this number is, square root it, and you got your radius. Easy as that. Okay? So when I have x squared plus y squared equals 9, what you got? You got a circle centered at 0, 0. Radius, what's the radius on this one? Radius would be 3, square root of 9. Square root of that number. Now, if you know it's a circle centered at 0, 0, radius 3, can't you graph it? Yeah, you can graph that thing because all you have to do is go to the center. Here's my center. The radius is 3, so if I go out 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 here, 1, 2, 3 there, there's your circle. So go forwards, backwards, right, up and down, and you can get your circle. We said probably the easiest of the graphs to make. Okay? What about this one? One more of those. What about x squared plus y squared equals 21? Well, that's a circle centered at 0, 0. Radius is, what's the radius there? Well, that was not such an easy, nice radius. The radius would be square root of 21. Well, it's not a nice number, but it is a number. Square root of 21 is thereabouts 4.58. And so to graph, just to go out from the center of this one, 0, 0, go out 4.58. 1, 2, 3, 4.58. 1, 2, 3, 4.58. 2, 3, 4.58. There you go. So you can do those as well. They don't have to have a nice radius. You can have a square root that's not nice radius. Okay? All right. The ellipses, well, they're not too bad either if you got them in the proper format. So let's talk about that. Is that okay? Okay. Yeah, ellipses, we saw them one of them we did looked like this. X squared, and we're just using a and b for just a squared and b squared for just the numbers. It could be 16 and 25, whatever the case may be. Yeah. So, for example, x squared over 9 plus y squared over 4 equals 1. That would be an example of that. On the ellipses, though, you generally want the a squared to be bigger than your b squared. You don't have to have it that way, but if you have the other way, you could have it the other way here, where the a squared, the bigger one's under the y. And it all plays out. Yeah, so that just means the a, generally want the a bigger than the b, so That's the only difference there. X squared over 25 plus y squared over 36 equals 1. Okay? That's the only difference. The a squared, you generally want it to be the bigger one. Okay? But yeah, these are ellipses. This one would be the one that's longer than it is wide. And this one would be taller than it is wide. That's the only difference. Okay? It's because the A, which one has the bigger number below it? Okay. Now, we didn't talk about the focus of a circle because the focus of a circle is the center, always. So it's not quite as exciting. We'll do these here in just a second. I'll show you how to do these. But let me also give you here the deal on the focus. Turns out on an ellipse you have two focus points, foci, sometimes they're called, and they're inside the ellipse along what's called the major axis. The major axis is just the longer axis of the two. So in this case, that's focus 1, that's focus 2, or vice versa. So you have two focus points, foci, on an ellipse. Now what we do is we call, and they're supposed to be the same equal distance there, what we do is we call the distance between the center and the focus, we call that C, not to be confused with P on the parabola. So C is the distance from the center to the focus. On an ellipse. Okay? And it turns out that, and of course you got C here as well. So it's backwards and forwards along the major axis. Well, it turns out C is equal to, or C squared, one way you can put it, is that distance squared is equal to the difference A squared minus B squared. And so that's the focus formula for an ellipse. C squared equals A squared minus B squared. Now, over here on this one, since it's taller, the major axis is here, and so your focus points are here and here, you see. So it's always along the major axis. But that's still C there and C there. Okay? All right, so how do we, so that's how we compute it, and we'll compute those in a second. Okay? So those kind of the general format of it. All right, let's do a couple. They're really not too bad. All right, so let's say we've got the x squared over 9 plus the y squared over 4 equals 1. Format of an ellipse. Here's how we're going to graph. We don't have to use a table or anything like that. We can just go right here to the graph. Turns out what I'm going to do, this is centered up at 0, 0, so it's an ellipse. Right? It's in that format that we've seen a couple of times now. That's an ellipse. The center, there's no shift on it, so the center is at 0, 0. And here's how I go about graphing this. Notice I've got x squared over 9, so if I take the square root of 9 equals 3, if I go out in the x direction 3, forwards and backwards, that's going to be 2 points on the ellipse. Guess how much I go in the y? Got the square root of 4 in the y, which is 2, so I'm going to go 2 in the y. Up and down. Connect those up elliptically. There's your ellipse. Okay, all the other points would fall basically in line with that. Okay? Now, one other quick point before I do the... there's two, instead of just one vertex, so we've got a circular deal, there's two vertex points, or vertices. And it turns out they're just the endpoints of the major axis, the longer axis. So in this case, the longer axis is here and here, so that point, which is 3, 0, and negative 3, 0, plus or minus 3, 0 if you want. That's the vertices. These points are not called the vertices. It's the endpoints of the major axis. Okay? Well, let's talk foci here. Well, again, it's just a formula. C is the distance to the focus points. So c squared, we know, for an ellipse is a squared minus b squared. Well, in this case, what's a squared, what's b squared? This is a squared, and this is b squared. A squared is just the bigger one of the two. So the c squared is 9 minus 4 here. So that c squared is 5. So guess what c is? It's square root of 5, wouldn't it? Or 2.2, somewhere around about there. Is that right? 2.2. Am I thinking right? 2.2, yeah. 2.23. So the c distance is 2.2. So I go from the center to that focus point, it's 2.2. So, and it's along the major axis, so I go 2.2 and 2.2. So there's my focus points. Focus 1, focus 2, or vice versa. So those would be, let's just write them. Well, you can write plus or minus 2.2 if you want. Exact value would be plus or minus the square root of 5, comma 0, wouldn't it? That's 2.20, that's negative 2.20. So square root of 5 and minus square root of 5. So that's my foci. We'll say more about that later on. But let me do one more of these and then talk about the hyperbola. Let's talk about x squared over 25 plus y squared over 36 equals 1. So again, that's an ellipse centered at 0, 0. No shifting. We'll do shifting next time. Okay? Okay, so we're centered up at 0, 0 again. How far out in the x do I go? Well, in the x, I've got below it 25, so we'll go out the square root of 25, go 5 out in the x. And back 5 as well. In the y, go out the square root of 36, which is 6. 1, 2, 3, 4, 5, 6. Okay? And so one thing that, spread those out a little bit too much. Yeah, this one turns out, let me do this a little better. Yeah, I've got, this one's taller than it is wide, right? And so I've got one of these more vertical ellipses instead of the sideways ones. But it's because the y squared is bigger. The number denominator of the y squared, I should say. Which then tells me, what about my vertex points or vertices? What are they? Where are they? Are they here? They're on the y-axis, yeah. These are my vertices right here. Vertex 1, vertex 2. So that's 0 plus or minus 6. Okay? What about the foci? Well, the foci is a squared minus b squared, and that's why we choose the a squared to be the bigger one, because we want to subtract and get a positive number. This is going to be a squared, this is going to be b squared. That's really the only big change here. It's 36 minus 25, which is 11. C squared is 11, so c is the square root of 11, which is along about 3.3. Now, the other thing is the foci go on the major axis as well. So where do those go? Well, the major axis, the longer axis, is the y here. So I'm going to go 3.3 in the y. Here's 3.3, and then here. So my focus points are along the y-axis, because it's all on the major axis. So that'd be what? 0 plus or minus 3.3, or square root of 11 if you want to put the exact value. Okay? Question or concern? Now, one thing here, let me mention, is one like this. We'll just graph this one. Not do the foci here. 9x squared plus y squared equals 36, which you might at first glance say, hey, that's a circle. But it's not a circle because of this. I've got that extra number there on a circle. You don't want that extra number in front of it. What I want to do here is actually this is going to turn into an ellipse, which brings up the point, what do I want the ellipse so I can graph it looking like? Well, to graph an ellipse, I want x squared over a squared plus y squared over b squared, or vice versa, a squared b, equals 1. I can put that into that form by making that 1. How would I make 36 be 1 to make it look more like that? Divide by 36, right? We're just going to take everything, divide by 36. Divide everything by 36. That cancels, so I have x squared over 4. That's y squared over 36 equals 1. That's the ellipse format that I like. Okay. So yeah, that's an ellipse centered at 0, 0. Go out in the x, square root of 4, 2. And the y, go out the square root of 36 is 6. So that's the way I would do this one. Okay? So that's another vertical ellipse. So that's what you would do if you encounter one like that. Which you probably will on the homework. Okay. With me? Question or concern?